Good afternoon and welcome to today's webinar. My name's Charles Green, and here at Bellatrix, I'm responsible for creating our thought leadership. And here we frequently publish reports on the key trends in software and mobile development, covering topics ranging from agile development to machine learning to wearables. But one of the topics that we received the most questions about is blockchain, and more specifically about how organizations can create actual products based on blockchain technology. And as a result of this demand, we've decided to put together this webinar to provide some concrete advice and also a demonstration of building applications. So I'm delighted that all of you on today's call are able to join us for this session. And to do this and to dive into some of the details about Blockchain 2.0, I'm delighted to be joined by the head of Bellatrix's Blockchain Center of Excellence, Diego Bonelli. Diego, firstly, many thanks for joining us today. Would you like to introduce yourself to the audience?
Sure. Good afternoon, everybody. Thank you for joining. So, I'm a software engineer at Bellatrix. I've been working in software development for the past 10 years, doing DevOps, QA automation, and lately backend development. And now I'm currently, since I'm passionate about the cutting edge technologies and we have an innovation team here, I'm working on blockchain related activities for Bellatrix.
Super, thank you, Diego. And just very quickly, for those of you on the call today who are not familiar with Bellatrix, we are a leading provider of software development services with expertise in product and mobile application development, as well as focusing on many of the cutting-edge technologies that Diego mentioned. We really specialize in providing software innovation services on demand to our customers. We have development centers in Peru and Argentina and Colombia, as well as having offices in Silicon Valley and New York. I should note that today we will be live tweeting throughout the session using the hashtag blockchainBSF. So please do feel free to follow along on Twitter. But you can also use the hashtag to ask any questions you may have. Also, if you want to ask a question, you can do so using the chat box on the bottom right-hand side of your screen. And although we're going to be presenting for much of the next half hour, we have got some dedicated time at the end of the session to take any of your questions. But without further ado, let's jump right into the content. Diego, over to you.
Okay, thank you, Charles. Well, so this is our agenda for today. We will start introducing what do we call Blockchain 2.0. The term 2.0 refers mainly to a new application of the blockchain that which main feature is the support for a Turing-complete programming language. That is a programming language that would allow to solve any computing problem. Before 2.0, we had Bitcoin, and there was very limited scripting capabilities because the scripting language didn't support recursion or loops. Among other things like restrictions in memory capabilities. So that was the main innovation and what started the second generation blockchain. So we mentioned that we have a new programming language on the blockchain that will run. In this case, we will focus mainly on the Ethereum blockchain, which is the most popular blockchain of the second generation and the most widely used by the development community. And this code that we write to run on the Ethereum virtual machine are called smart contracts. They are not not necessarily representing a contract between parties. It's just that they could be general purpose pieces of code that will perform a predetermined action, and they are called smart contracts in general. One main characteristic that is worth mentioning about the smart contracts and any piece of software that you deploy on the blockchain is that it runs in an autonomous way And since it's decentralized, it doesn't have a single point of failure. Well, like we mentioned, having this Turing complete language allows to write the more sophisticated pieces of contracts, pieces of software, which are these smart contracts that we call. And the thing is, okay, we have smart contracts. How can we take advantage of them? And there are basic use cases that are these ones that we have on the screen. They might be more, of course, but these one are the main ones. This is identity, reputation, document registry, asset tokenization, escrow, cryptocurrency, of course, and electronic voting, just to name a few. The thing is that combining these use cases, you could get also more complex, again, use cases that will better represent the needs of the industry. For example, if we take the automotive industry, these smart contracts could be useful to track truthfully the history of vehicles from pre-production to sale, or supply chain part management. Banking and financial are, of course, a clear application for these smart contracts. We could streamline payments, empowering global transactions that currently have too many intermediaries, minimize auditing complexity, and so on. Another application to mention here would be charity, for example, where we could track donations and check accountability and integrity and reduce the overhead and complexity of donation payments processing. And many others like energy sharing, ride sharing, IoT for automatic transactions, payments, and transactions in general. And many more. Document registry, for instance, you can use it for healthcare together with identity and reputation. Like we mentioned, the previous building blocks are making these use cases. But without further add-on, let's see what is a smart contract, what it looks like in real life. So for that, I will change to IDE. Well, here, before that, I have just pasted a code sample for ERC20 token. This is from a tutorial that I will be linking in the last presentation, in the resources presentation. And as you can see, a contract looks very close to a JavaScript class. This is because this is written in Solidity, which is the most popular programming language for Ethereum. But let's write something ourselves. So for that, I will be using the Remix IDE. This is a very practical IDE to test smart contracts. The thing about this IDE is that you can deploy with one click, and it will show you a log on screen, and you will see now how it works. So here I have a simple smart contract. Maybe the simplest one you can think besides an empty one. And the first line we have to enter is directive for the compiler telling which version of Solidity you will be using for compilation. Then you write a contract like a regular class. It can have properties and functions. Then when you want to deploy the contract, you will have to choose a provider or an Ethereum node where you want to deploy. That can be an embed JavaScript built a machine into the browser. Maybe it's nice for testing, and we will be showing that. And let's see how it works. So we have auto compile on. So this is compiling, otherwise we can recompile. And then we say deploy. We are deploying with a dummy account that is provided by the Remix IDE and into the JavaScript virtual machine, and we see that it was successful. Now, if we go to the, we see here that after deploying, we get an address, which is where the smart contract will be residing. This address is important because if we were deploying on a public blockchain, we would be able to search for this address and look at the code, at the compiled code of the smart contract. Usually, developers would attach the Solidity code that belongs to that contract so that it could be audited and for transparency issues also. So let's see what we have here. It shows that we have a public property here, which is called counter, and a function that is called increment. You see, if I were to remove the word public here and recompile this, well, it's in auto-compile, so that I just need to redeploy. We see that we get a new address for the newly deployed smart contract, and the counter variable is no longer visible, but we could still increment that. And let's see that. Now we have in two addresses deployed two different smart contracts, the same but without the modifier on the counter property. And let's see what we have here. We can call. We see here call is a method of the Web3 API that is running under the hood, which is what allows to communicate our smart contract, our IDE with the smart contract. You know, the Ethereum built machines uses an interface that is called JSON RPC, but you probably don't want to implement the JSON RPC interface yourself for your application, and because there are development teams that have already done that and created a wonderful library that is called Web3.js in this case. And there is also Web3.j for Java, and Ethereum, I believe it is for .NET, which allow us to communicate with the Ethereum built machine using convenient methods like call. And call is a method that gets you a value and doesn't cost gas, which is a unit, the unit of cost that we have, that we incur into when we execute code on the Ethereum built machine. Depending on the operations, they have different costs. And you can see that on the documentation for the Solidity language. So here we are making a Web3 call to the address where the smart contract is residing and getting a value in return, which is unsigned integer 2.6 that it is here we didn't specify, but by default you have that if you say uint, you are meaning uint 2.6. It's not necessary to specify it completely. And we see that the counter is 0. If we were to increment, we see the transaction. In this case, we, instead of using call, we are using send transaction method. And it should have increased the value of the counter. So if we call again the counter, we see that it was incremented. The same would happen on the other smart contract, which is residing in a different address, just that we are not able to see the value because it is not exposed. Okay, so now what about using, we probably don't want to just use the JavaScript virtual machine into the browser. We want to communicate with an actual blockchain. And for that, we have several options. We could use public testnets. We could use the Ethereum production network, which will spend our Ether, and we should have Ether on our account in order to use it. So probably for development and testing purposes, you will be using a testnet, which is very close to the main production testnet. We can see here, this is a plugin for the Chrome browser, which is called Metamask, and works like as a software wallet. And this is what will allow us to expand Ether and communicate to the and send transactions to a blockchain when we are not using just the integrated JavaScript virtual machine. The thing is that why do we need a plugin? We need a wallet. Could we build the functionality of Ether wallet into our application? Well, probably yes, but we wouldn't want to do that because managing keys and accounts is a very sensible thing. So if I were working with real Ether, probably I wouldn't be using even Metamask. I would have been using a hardware wallet, and Metamask would allow me to import an account from a hardware wallet also. You see here the option for connecting a hardware wallet. Since, you know, Ether, like Bitcoins and cryptocurrency in general, is a precious asset, you don't want to treat it like lightly. Okay, so let's see what other options do we have here. We could be using the main Ethereum network. Rockten, Koban, and Rinkeby are test networks. The difference between them will be the mining algorithm. Some would use proof of stake or some other different algorithm. We know that Ethereum is still using proof of work, same as Bitcoin, which is a very costly mining process. So for convenience, for practical reasons and convenience, most testnets are using other algorithms, other consensus types. And we could also specify local nodes. What are these local nodes? Okay, so we could have a console node. One very popular that was now replaced with Ganache is called test RPC. For example, let's say, let's build, launch a test RPC node. You might be wondering, how do we install test RPC? Okay, test RPC, you just have to do an npm install, provided you have Node.js installed into your system. I will be linking the download link for test RPC at the end of the presentation with the other resources. So don't worry if you, anyway, you will be able to just Google test RPC and you will find the GitHub project where there is a nice explanation on how to install it and use it. And as you can see here, when we launch test RPC, we get 10 available accounts, and they all have, I believe, 100 Ether of balance. And the private keys that we will need to import these accounts into, in this case, our Remix ID via Metamask plugin. And it's listening by default on port 8545. So we have it here as an option by default because it was a very popular memory node. And this one that I have currently selected is for Ganache. And Ganache, let's start another one. Is this this newer blockchain node which also works in memory and has the advantage that it provides a nice graphical user interface. So if you go to the Truffle Suite website, the Truffle web framework that we will be talking about later in this demonstration, you will see that this is the recommended blockchain node for Ethereum development instead of testRPC, which is being used less and less because it doesn't have a graphical user interface. But okay, let's see if we say, okay, we want to connect to testRPC just to see what happens. We see here that there's already some output here on the console. So it's trying to connect. I will have to reload the IDE in order to use it properly. And we see, okay, we are connected here. And let's import some account from our testRPC node. Let's say we want to import account and we will access the private key and we will say, okay, maybe this one. And we will paste that here, paste, import. Like I mentioned before, I was right, the default balance is 100 Ether. And now if I redeploy the contract, instead of using our previous JavaScript virtual machine with embed Ethereum node into the browser, we will be communicating with this node using the Web3 API that it will be our intermediary in between our Remix IDE and this Ethereum node. So now we can redeploy. And it says, okay, pick an account and confirm there is a gas fee and it should be deducted from the balance of our account. We say confirm. So something didn't work. Let's try again. Oh, okay, so no, the port is right. Let's cancel this. Let's see what happened. So let's go again to the, okay, so the account. Okay, so we said we were using this account, number 3, I believe. Sorry. And we will tell it to use that account. No. Web3 provider, of course. Yes. Here we will say, okay, we want to connect. No, yes, 84 is listening on this port. We said that this node is listening on that port. We say, okay, now we have all the accounts available. Okay, I don't remember which one we were using. We will just pick a random one. Now we will redeploy. Maybe we can't just choose any account. Let's see. Okay, 100 Ether. This one has less Ether. Let's see what happened. Okay, so the thing is that we have Metamask also connecting to this node, and we are trying to use a custom provider here, so it's making a conflict because it's already taken. But let's clear this so we know that when a new contract is deployed. Let's see what we have. This is nice to watch. Okay, so this is what you will normally see in Etherscan if you go to see a transaction block after you send something to the Ethereum network. This is convenient using Remix because if we were using Visual Studio Code, for instance, and we are not logging the callbacks, it will be difficult to see this output here. So it basically says the account and what was the gas price and all the data belonging to that transaction. And so I still want to deploy this. So let's try to pick another contract, another account, I mean. And okay, let's close this one. We will start a new node. Okay. Somebody's connecting to the node. Let's see which account do we have here. Okay. Account 6 starting with UB50. So do we see that one here? Okay, this one. It has 0 ether. Okay, so if I send it, contract pending. Oh, right, it worked. It was a matter of just restarting the node, because sometimes it gets stuck with a previous connection and then it will refuse new connections. So we can see the contract was deployed, and we don't have the public counter. I want back the public property, and let's redeploy again. It worked. Let's see again. Okay, so this one is using the Metamask, and the previous this one was directly from Remix. So let's try back get Metamask. We say confirmed. Okay, this is okay. So this is a good reminder that when you're trying to use 2 different connections to a Ethereum node, you can be using Metamask and the Web3 and the Web3 provider from Remix, and they will cause conflicts. So let's just log out from this one and say, okay, I want you to log out. Log out. Okay, now it won't connect to my test RPC node. Oh, actually, I could have done something better. Instead of saying that I want to connect to the Ethereum, to the test RPC node, I could have connected to Ganache, which was my other open blockchain node, and it's a good opportunity to test that. Okay, so now we have a bunch of accounts to test, and we see that the new increment, there's some warnings here that we could be checking, but the thing is that call worked, and it has deployed the contract on this node. But the thing is that here we are not seeing we don't have a block explorer to mention to see what has happened on the blockchain. One important thing to do if we were using the MetaMask to connect to the Rosten network, for instance, we will be able to use Etherscan to check the Rosten network and check this transaction. Okay, but I think that the usage of blockchain of Remix any of the web providers to connect to different nodes is clear by now. Maybe we could add here something like decrements or well, but it would be more of the same if we were to add more functions. We will just having here more operations to perform on the node, and the thing about smart contract is that they can also perform calls to other smart contracts, but they cannot perform calls to outside web applications. So what they can do is listen for input for other web applications, and that will lead us to our next topic, which is, okay, we've seen smart contracts, right? And when they look something like this, and we were able to connect to an in-memory node, we know we can use public testnets. And here, well, okay, so here I have another example, a bit more complex, but it's still incomplete. For instance, if we were creating a voting smart contract, we would need a candidate and a voter. And the thing is that here we are creating some hashes tables to store the votes. And maybe we could be also, I mean, this is incomplete, right? We just have a function vote that will be incrementing the votes for a certain candidate on behalf of a certain voter ID. But probably we would like to check first if the candidate ID exists on our list. But I think it's a good example to show that what another kind of contract would be looking like. Okay, so we have the smart contracts. We say, okay, we can develop on the Remix IDE. We could be using Visual Studio Code and then the Truffle network. And I will show that to you now. Because when you want to construct distributed apps, besides developing your smart contract, which is fine to develop on the Remix IDE, you might want to add some JavaScript front end, or in your favorite language, of course. And you would like to have these contracts and the rest of your application on a project structure, and that is where the Truffle framework comes in. So, okay, I will talk about this calls to a smart contract later, because let's first go to an example of a distributed app. So I will go here to one directory, blockchain. Okay, Pet Shop is a common test application that if you are familiar with Spring Boot and the typical Pet Shop application. Also, we have one from the Truffle guys and the Truffle framework that they provide a tutorial to create a Pet Shop application, and it looks something like this. And we see here that this is a project structure typical of a Truffle application. You just type Truffle in it like this. I will create a new directory. So we have an empty directory. We do Truffle in it. To install Truffle, also the links will be provided on the resources presentation at the end. And you just do npm install Truffle, and you get the package for the Truffle framework. And it says here some useful commands for Truffle. Let's see what we get here. You see, they create you a folder for the contracts, migrations that will be the deployment process of your contract into the node that you will configure on this file. So let's go back to the pet shop example, since I want to show you working the app. We see here we are specifying 7545, which is our Ganache node. You see here 7545, which is running. So just in case, I'm going to close the remix IDE so we don't get any conflict because of the port being already busy. We say, okay, we want to deploy here our local host and on this port. This is where our blockchain node is residing. Then we have some contract, which is adoption, which will be called from the web UI using a JavaScript call. And then we have some deployment instructions. We say here we will be deploying the adoption solidity contract. And before that, I'm going to go back to the presentation that we will that I was about to show you earlier. And you see here that I wrote some steps to call the smart contracts. And the thing is that when you wanted to do it manually before the Truffle framework, the steps were these. You would open you will have to load the Web3 API, and you will do that by, for instance, let's show it on a node console, just to give you a better understanding of what I'm talking about. Let's say I said node, yeah, and go into the node console. So I want to all the steps because it will be too boring. But the thing is that the steps here that says load web3 would look like something like this. Like we are somewhere we have to store the web3 library. So I will say this. Okay, so we have to first npm install web3, and okay, but I don't want, since we spent so much time on the remix IDE, I don't want to go back to installing npm. Let's exit this. So you will have to do npm install web3 in order to have the module for web3, then require that, and then do a manual compilation of using a Sol-C compiler. You see, if you say, we go here and we say Truffle version, we see that version, that Truffle is using the, well, a version of Solidity and Truffle, and we also have some Sol-C as part of Solidity, a compiler for Solidity. And this compiler will, something that we'll create will be an API, which is a JSON representation of the contract interface. So we will call a method from Web3, which will extract the interface and save it on a variable. Then once we have that, we will compile, we will read the Solidity file and convert that to a string, and store it in a variable, and then tell the compiler to compile the content of that variable to get the compile code that will be pushed into the Ethereum virtual machine. So once it is pushed, you will be able to use Web3 methods like call or send transaction, and then get in return a callback and see the mine transaction and the state changes. This was happening under the hood when we were deploying on the Remix IDE. And just like it happens with the Ethereum IDE, which was happening under the hood, you don't have to do these steps anymore, but it's always nice to know what's happening. And you will see that, okay, so what I was just talking about, right? About requiring the provider, okay, so I forgot to I had to require the module, then I would be able to instantiate that and then parse the interface. And this is nice nice look at a voting contract that once you compile it and you send it to the Ethereum node, you get an address for where the contract was deployed. We saw that on the Remix IDE on the right column, and then you enter here the address of the contract, and once the contract is instantiated, you can just call the constructor or the vote method that this is related to the previous method that we say here, the voting app. So we had a function vote. So here is function vote that was voting for a candidate. Okay, so let's go back to our example of the pet shop. Right? This will be the most interesting part. So let's say, okay, we will be using Ganache, right? So I don't need to start test.bc. We see Ganache is, not this one. Ganache is listening on port 7545, right? Okay, so let's see. Okay, we will have the adoption solidity and the deployment. Let's see if this works. So we will go to our this directory that is here, pet shop, right? And we will do an npm install just in case. And let's wait for that. A few seconds. Okay, now that is done, let's run the. Okay, so let's deploy. Truffle migrate. This will run our migration into the Ganache Ethereum node. Okay, so let's see what it could fail. It's nice to know. Let's see. Okay, so we said we are on the right directory. Yes, we are on pet shop. So we want to use this one. Let's try. This is okay. This is okay. Just in case we are restarting this node. Let's do a truffle test. Okay, so it's working. Let's see if we do an npm run dev, because we are using the development network. We said here that we are using development modules. And it should be launching our web application that looks like this. Like we mentioned, we had a smart contract that it says adopt. So we have here a button that should be calling that method, because we have scripts for that we use here. We have the minified version of Web3 in order to communicate with the Ethereum node, and then we have the truffle contract and our JavaScript, all which was here. previously. Okay, so this is the adoption solidity that we are going to call. So let's see if we adopt one. Are we? Okay, so no, sorry about that. Click the wrong icon. Okay, so the thing is, I'm not connecting to the node. Why is that? We should know by now that in order to connect to a Ethereum node, we need a provider. So the application doesn't have the ability, like we mentioned, we don't have the wallet functionality built into our application. We need some third-party provider for the account management. So let's go open back our Metamask, and we say, okay, now we want to communicate to our Ganache node, that is this one. Back to the wallet, customer PC, this one, okay. Okay, so we are not connected to our Ganache, and I don't know if we have an account that is already from a previous attempt. Let's pick one here. You see here, okay, I have been using this account previously, so let's use this one. It has 100 Ether and no transaction counts. Let's get its private key, and we'll say that to our Web3 provider that we want to add a new account. Okay, import a new account, this private key, import. Okay, it has 100 Ether. And now we want to adopt. And you see, like before, it wasn't doing anything. And now it says, okay, account 3 will be sending with this gas fee a smart contract placed on this address. We confirmed. And now it works. Unlike before, and okay, we can see this on EtherScan, of course, because we are using Ganache. But if we were using the real Ethereum network, we will be able to go to EtherScan and see the transaction where this pet was adopted by me, and with the account details of the one performing the transaction. So yes, finally we got a successful demo. I hope you enjoy the troubleshooting, because it's important when you try to do it yourself. You will see that it usually doesn't run good on the first try, and you have to figure out what's going wrong. So hopefully this will help you out. And let's go back to our presentation to see what we have left. So yeah, so some resources about what we have seen. The Truffle Framework website is a great work to start. There you have Ganache, which is our graphical user interface node for our in-memory blockchain node. The testnet PC also, if you feel comfortable with the command with the console. And then a token tutorial, which is a tutorial using Open Zeppelin to build an ERC20 token, smart contract. The pet shop, and the tutorial for this application that we have just run on this demo. Some blockchain papers that are always interesting to have handy, but in case you want to get some implementation details on blockchain. The Remix Solidity API that we were using at the beginning of the demo, and then on the website for the Web3 API, which is the one that we were using across all the demonstrations today. And with that, I'll move back to Charles to see if we have questions.
Super, thank you, Diego. It's been a fascinating presentation through all the different aspects of creating smart contracts. I want to take this opportunity to remind everyone that if you want to ask a question, please do so, either using the hashtag blockchainBSF on Twitter, or you can use the chat box on the bottom right-hand side of your screen. And Diego, actually, whilst you were presenting, we had a few questions coming in. So I want to jump straight to it. The first question is, can I use other programming languages to make dApps and code smart contracts?
Yes. We could use other programming languages. And there is, we were using just now Solidity, which is very similar to JavaScript. But if you are familiar with Python, maybe you might want to check Serpent, or I believe now it's called Viper, which is a newer version, or I don't recall which one is the newer version of the other one. But certainly there is another programming language that is supported by Ethereum. Other blockchains will have support for other programming languages. And as for the dApps, you can code in any language you want, as long as you import the proper library to implement the RPC, the JSON RPC interface. Because we were using Web3.js, because we were using Node. But if you were writing in Java, maybe you will import Web3.j, which is the equivalent library for implementing JSON RPC for Java.
Yeah, super, thank you. We have another question which just come in, and that is, will blockchain companies ever be able to distance themselves from Bitcoin so that the technology can mature without the stigma?
Yes, the thing is about Bitcoin, I don't foresee the future with only one blockchain. I believe that Bitcoin will continue to be a major player in regards to cryptocurrency, but when we are talking about general purpose or industrial purpose blockchains like Ethereum, which is more focused on developing distributed applications, blockchain and these blockchain companies are not trying to compete with Bitcoin. Bitcoin is like our gold equivalent on cryptocurrency world, and as a cryptocurrency, it will be hard to overtake in market share and importance. But what other companies are doing, especially with the new generation blockchains, is to focus more on the smart contracts, which is something that Bitcoin doesn't do. So they are different things. I don't see Bitcoin competing with Ethereum, for example.
Mm-hmm. Yeah, I think I certainly agree with you there, Diego. And I think it's a really fascinating question. One thing that comes to my mind is Jamie Dimon, who's the CEO of JP Morgan Chase, and he's called Bitcoin a fraud, but at the same time, JP Morgan Chase is spending a lot of money developing new kind of blockchain ideas and technologies, experimenting with blockchain. So there are these two aspects that on one side he says it's a fraud, but at the same time his bank is spending a lot of money developing blockchain technology. We have a further question, and that is, do I need to spend Ether in order to use a public testnet?
That's an interesting question, because yes, you actually have to spend Ether. The thing is that when we were using our test accounts here on the local blockchain node, we just had a few accounts with balance by default. And when you are using a public testnet, you will have to send Ether, but as long as you are using a testnet, that Ether is not real Ether. It's an Ether that only works for the testnet. So there is a website that, for instance, if I want to create, I think I'm gonna show you that. So because it's not in the resources, and if I want to use, for instance, Rinkeby testnet, I will go and browse faucet Rinkeby, for instance. And for this, on this website, they will ask you some social network credentials. And once you do that, they will assign Ether to your account, so you can spend that Ether on your developing apps when using the Rinkeby faucet, the Rinkeby network, like we mentioned here. So yes, you will have to spend Ether, but it's not real Ether. It's Ether that you can just ask, and it will be assigned to you.
Okay, super. Thank you. I see we have just one last question. So if anyone else has any other questions that you'd like to ask, please do so now. But we have one last question waiting for you, Diego, and that is that I've already heard that there's a blockchain 3.0. What is new about this third generation?
Yes, that's right. So there are some new blockchain projects that they are being called the third generation, but the focus in this time around is on high scalability, sustainability, interoperability, privacy, governance, those aspects that the second generation didn't put too much focus on at the time. So yes, those are the main features of the third generation. What can we mention? Cardano, for instance, is one working on such scalability and interoperability issues. The thing is that we would like blockchains to interact with each other, to have side chains. There is EOS also on that third generation. For instance, Ethereum, which is a second generation blockchain, is working towards solving some of these challenges. And we saw that with the proposal to change the consensus algorithm to proof of stake. Also with sharding and the Raiden network, which is something like the Lightning network on Bitcoin. So maybe it's not that Ethereum will be stuck on the second generation, because if after all these projects comes into fruition, I believe that Ethereum will become itself, will evolve into the third generation also.
Okay, super. Many thanks. I see at this time we don't have any further questions, and I know we're nearly at the top of the hour now, so I think this is a good time to wrap up the presentation. Firstly, I'd like to say many thanks to you, Diego, for sharing your knowledge and your expertise. It's been a fascinating presentation. Also, thank you to everyone who took the time to join us today. I hope this has been helpful and useful for you. Just if you would like to find out more about the work we're doing regarding blockchain and the work we're doing in our Center of Excellence here at Bellatrix, then please don't hesitate to reach out to us. You can do that either via our website or via social media. And really just so you understand that our Center of Excellence, led by Diego, is really responsible for exploring many of the latest developments in blockchain and helping to guide our customers through the technology and helping them make those decisions. So please don't hesitate to reach out to us regarding that. Diego, do you have any final comments you'd like to leave the audience with?
I just hope that you find this the programming side of smart contracts interesting, that this has been helpful to you all. Just to get started, hands-on on blockchain 2.0 and smart contract development and distributed apps. And just thank you all for joining, and it's been a pleasure.
Okay, excellent. And just to remind everyone that a recording of the session will be available within the next 24 hours, and you can find that either on our website or on our YouTube channel. With that, thank you once again to everyone, and wish you all a very pleasant rest of the day.